Good morning, my fine students. This is Jessica Langbart back at you for the review for Section 10 Key. Alright, look, excuse my voice. I'm still trying to get over whatever virus I caught these last couple days. So, in any case, here we go. Solve for A, W, X, and Y for number 1. Right, so we've got a nice little trapezoid here. You've got the mid segment because you've got these nice little markings that show this will be a midpoint and midpoint, which makes this a mid-segment of the trapezoid. And so let's start off with A. If I want to find A, we can do this one of two ways. I'm going to go for the easy way first, a little bit of logic. What's the distance between 70 and 56? Right, so if I just take 70 and subtract 56, that distance is 14. So I know the distance from 56 up to A is going to be the same thing. Yeah, distance of 14. So all I'm going to do is take 56. I'm going to subtract that 14. Boom shakalaka. A is equal to 42. Alright, now, as far as the method, the actual method to the madness is the mid segment is equal to half base 1 plus base 2. So you want to make sure that I did this right. The mid segment was 56 is equal to half. We didn't know the base 1 for a second. There was A plus 70 is the base 2. So if I solve this, I can multiply times 2 on this side, times 2 here. Alright, 56 times 2 is 112, equal to A plus 70, and then I can just subtract 70. And we would come up with something like 42. Oh, look, we got the same thing. So this is the actual method. This is just a quick trick to get you what you need beginning. A little bit earlier. Alright, so then if I want the other angles, fantastic. Okay, so note, in a quadrilateral, if you don't know how many degrees are any polygon, for that matter, it's n minus 2 times 180, which we got to know for the FSA, n being the number of sides. So in a quadrilateral, we've got 4 sides. So if I do 4 minus 2 times 180, give me 360 degrees. So there's 360 degrees in any quadrilateral, and that's going to help us out with this problem. A few different things that you could use would be things like parallel lines. They give these cute little arrow markings, meaning parallel lines. Great. So if I wanted to maybe start off with this side right here, this transversal cut across these two parallel lines, rather, I know that these two angles will add to be 180. So all I got to do is take 180, subtract 60, and that will give me 120. So X is equal to 120 degrees because these guys are same side interior angles, meaning they add to 180. Same thing over here. I can do the same exact thing. Let's see. But in any case, let's start with W. So the mid segment is always going to be parallel to both sides. So you could really do the same thing with W and 55. So if I'm looking at W and 55, again, these should add to be 180. Okay, so let's take 180, subtract 55. Let's see what that is. Oh, excuse me. And that would be 125. So W is equal to 125. And I know W and Y are on a line. Again, at a line at any point, there's 180 degrees. So 180 minus 125, again, is going to be still 55 degrees. And you want to really know something fun? Y and 55. They're on that transversal. Here's some parallel lines. Those are corresponding angles. Yeah, bringing you back. So there we go. We got A 42, X was 120, Y was 55, W is 125. Number 2, perimeter is 95 units. Solve for A, X, and Y. Alright, based on these markings, looks like we got a kite. Okay, so about a kite, symmetrical, which is really cool. So this distance is the same as over here. So I'm going to put a 22 here. Alright, let's keep rolling through this and see what else we can figure out. So the perimeter is all the way around, it's 95. You know that this side and this side is 22. So let's do this, 22 plus 22 plus side A, which this would also be side A. That's all my perimeters, all my sides added together gives me 95. So we're just going to basically solve for A. No big deal, right? You got 44 here. Let's subtract 44 to both sides. Those all cancel. This is a plus a, which is 2a. Let's subtract 95 minus 44. It's 51. Divide by 2. All right, we're going to have 25.5. That's decimals. Okay, we're all right. All right, so there's a. All right, so we know a is 25.5 here and 25.5 here. You just want to double check your math. Make sure you did it all right. Just to add all your numbers up together. Make sure you did it all correct. And boom, shakalaka. Again, we did it. There's my perimeter. Okay, so A is done. Check. Still got to find X and Y. Okay, so again, we already discovered in a quadrilateral there are 360 degrees. And in a kite, it's symmetrical, which is great. So this angle is 94 degrees. This angle here is also 94 degrees, making X 94 degrees. Alright, so to find Y, I'm just going to come over here where we know again there's 360 degrees in a quadrilateral. So let's just go ahead and do 360. We're going to subtract all the other angles added together. So you got 94 plus another 94 plus, I'm running out of room, 33 there at the end. Okay, so, you know, I don't care how you do this. I'm going to do 360, subtract, in parentheses, 94 plus 33. Or you could add those first and then subtract your two numbers. Either way, we're going to get Y, and Y is 139 degrees. Again, if you want to double check your numbers, just add 139 to 94, 94, and 33. Should come out to 360 degrees. Alright, rolling on to number 3. Michael plots and connects the following points. Which best describes the quadrilateral form? Alright, so let's plot it. -4, -2, +4. Alright, there's 1, that's A. B is 2, 4. C is 4, 2. And D is -4, +2. Alright, so if I connect those, that makes a lovely trapezoid. Very nice. Very nice. Alright, number 4. What is the perimeter of the kite shown? Okay, so a kite is the distance all the way around. Okay, so knowing a kite, I know the diagonals are perpendicular to one another, which means we got 4 different right triangles here. Yay, right triangles. And when we have right triangles and we've got 2 sides, you got to remember we're using Pythagorean theorem all across the board, okay? And specifically, if you can remember some Pythagorean triples that'll help you, like 8, 6, and you just knowing what the third side is. If you don't remember the triples, which are just perfect, no big deal, right? No big deal. So if I look at this first triangle, 8 and 6 are your A and B. So we got 8 squared plus 6 squared equals C squared, C being this side here. Alright, so that's 64 plus 36. Add those together, it gives me 100. Take the square root. C is equal to 10. Alright, so that's a Pythagorean triple. And in a kite, we're symmetrical, so we also got a 6 and 8. No need to do that again, that's also 10. Alright, now we got to get this side here and this side here. Alright, same idea, Pythagorean theorem. Alright, so I'm going to do 8 and 12. I'm going to figure out this side. So I've got 8 squared plus 12 squared is equal to C squared. We got 64 plus 144 is equal to C squared. We add those two together. What is that? That is 208. Take the square root of both sides. Alright, alright. Square root of 208, oops, is something silly looking. Alright, so if I want a decimal, again in my calculator, hit the little arrows. Alright, 14.4222, yada yada yada. Okay. Alright, so, and I didn't tell you what nearest decimal to round to, so in any case, we're going to try to keep everything as exact as possible to the end. Alright, and remember we are finding perimeter, so we can add all this around, all the way around. So if I've got 2 of these, I'm just going to multiply this. Go ahead and multiply it times 2. That adds these 2 together, and then we got to add the 10 and 10, which is 20. So add 20. Alright, so my perimeter in its most exact form here is this decimal as such. Perimeter, let's round it to the nearest hundredth. it would be 48.84 inches. There we go. There's my perimeter. All right, moving on. Number 5, a squared graph on the coordinate plane has diagonals with lengths or endpoints here and here. Okay, so 0, 4 is here. That's E. It's an endpoint of a diagonal of a square. All right, and 1, negative 3. 1, negative 3. All right, so this is one of the diagonals of a square. So just putting that in perspective, if I have a diagonal, and I'm just going to draw this maybe over here. Diagonal of a square, you know there's 2 diagonals of a square, and we know they're perpendicular, and they're all congruent in a square. So if you connect to those, the square is going to look something like this. All right, so the question is, what is the question? Okay. The question is not posted there, but this is what we're supposed to do. We're supposed to find the endpoints of the other diagonal. Okay, so we know these diagonals are perpendicular. Alright, perpendicular. So when we're on the graph, you got to think automatically, okay, this is the slope. We need the perpendicular slope of this guy and to figure this out. So let's roll. Okay, wow, sorry. Okay, so what I'm going to do, I know slopes are opposite reciprocal. So I'm going to first figure out what is the slope of this guy. But the thing is, because the diagonals bisect each other, meaning they cut each other in half, first thing I'm going to do is actually find the midpoint. Alright, so midpoint, don't think too hard in this, just visualize it, right? We go up 1, 2, 3, 4, 5, 6, 7 over 1. So let's just cut both of those in half, and you'll find what you're looking for here. Alright, so half of 7 is 3.5. Alright, so 3.5 here, and then half of 1 is 0.5, so my midpoint's right there. Okay, so from that midpoint, I'm going to figure out what's the slope from my midpoint to E, or you could go from the midpoint to F, does not matter. Figure out that slope, then do the opposite reciprocal, and from that point we'll figure out where the next diagonal is going. So, if I was going to figure out the slope from here to here, it's rise over run. Okay, so it's going to be nasty, but it'll be alright. So we go up 0.5, and then 1, 2, 3. So we went a rise 3.5, and I ran to the left 0.5. Now, this slope is negative, so I'm going to put a negative. So the slope of this line is essentially 3.5 over 0.5. Ugly. We don't normally do decimals, but it's all good. So if I want the opposite reciprocal of this guy, we're going to flip it. So it's going to be 0.5 over 3.5. And where this was negative, now we're working it with a positive. Okay, so from that same point, let me get a different color. Green. I'm going to go up 0.5, rise up 0.5, run 3.5. So up 0.5 will just go up to the line, and then we're running 3.5. So there's a 0.5. Then I go 1, 2, 3. Boom. So again, I went up 0.5 over 3.5. And you can go back the other way. So to the left, 3.5, down 0.5. To the left, 3.5, so 0.5. 1, 2, 3, down, down 0.5. So here we go. There would be my other diagonals. So answer the question, what are the endpoints? One endpoint would be at 4, 1. The other one looks like it's at negative 3, 0. Alright, so 4, 1, and negative 3, 0. Those are my answers. And if you want to check, if you just connect your dots, you should make a really pretty square. Oh, it's lovely. Alright, and you can double check if you really wanted to. You could check essentially, like if you created, I'll do this with a highlighter, you did it right, you made like a triangle, a right triangle with all, like with every corner, they should all be like the same based on height. So it looks like I got a 3 by 4. Next triangle, 3 by 4. Next triangle, 3 by 4. Next triangle, 3 by 4. Cool. So they're all the same dimensions, which means all these lengths will be the same, making this a very nice, pretty looking square. Very cool. Alright, rolling on number 6. Number 6. Okay, so again, you've got a trapezoid. You've got some midpoints here based on the markings that they give you. Cool. So again, I know I can use that formula we talked about in number 1, or you can just use a little logic. So what's the distance between 36 and 17? All right, because we don't like to use our brains all the time. We'll just use a little calculator. All right, the difference is 19. So I'm just going to add 19 to 36 to get Q. Oops. 55, and I'm done. Done. Again, you can use the formula if you want. It'll work the same. 7. In kite, ABCD, find the following angle measures. Alright, sorry, there's some white space there. Oops. Okay, we know it's a kite. They tell us it's a kite. They got the markings for the kite. Great. So we know in a kite it's symmetrical. Obviously, like, we would cut it right here. Okay, which means this angle is the same as this one. And we know there's 360 degrees in any quadrilateral. We covered that in the beginning. So I'm going to add 60 to 44. And then I'm just going to take 360, which is the total, and subtract that 104. Let's see what I get. And so I'm left with 256. I got to divide it by these 2 wings of the kite. So if I divide that by 2, you know, that's going to be something like 128. So right here is going to be 128. This is 128. You can check your math. If you add up all your angles, it should equal 360. And now we just need to follow the letters to look for what the answers are for these 4 problems. Easy points here, ACD. So if I follow A, C, D, we're actually talking about the angle here. Now they said this whole thing was 60. If I cut that in half, and that's the angle I'm talking about, we're just talking about that middle letter, AC, D, that's going to be 30 degrees. All right, ABC. So A, I follow it. B, C, we're talking about the middle. We're talking about that middle angle. That's 128. We already figured it out. All right, if I go BAC, all right, so A, B, A, C, we're talking about this angle here. Remember, this whole thing was 44, so we take that in half. That's 22. And then ADC, all right, so A, D, C, D is that middle letter. That's what we're looking at. That's 128. Cool. Excuse me. All right, the endpoints of one diagonal of a quadrilateral are the following. Okay, it's the diagonal. It's important. Endpoints of the other diagonal are as follows. And then they ask us some information here. So let's go ahead and graph this. If I notice I don't have a very big graph here, but all my numbers are positive. And on the x coordinate, the smallest number I'll need is 4. Okay, the biggest number I'll need is 12. So my x graph, I'm going to go from 4 to 12 on the x-axis. On the y, you know, you get a 12, a 2, a 12, and an 8. So the smallest number I'm going to need is a 2. Biggest number I'm going to need is a 12. Alright, so just a way to kind of save yourself a little space here. I'm on here, I'm going to go ahead and graph right down here. It's my x-axis. And we're going to start off somewhere special here on the x-axis. I'm actually going to start with 4. Let's just put 4 right here. And over here I'm going to start with 2 being right here. So kind of like moving our graph over just a little bit. Okay, so if I'm able to do this, 7, 12. Okay, so this is, let's just go ahead and graph. Let's see, 8, 10, 12, 14. Don't need to go that big, that's right, 2. Alright, here's 4, 6, 8, 10, 12, 14. Okay, alright, so let's go ahead and graph our points. We got 7, 12, so 7 here. I'm going to go up to 12. Alright, there's W. 12, 2, 12, 2. There is y. X is 12, 12, 12, 12. And z is 4, 8, 4, 8. Okay, so they said this. They said the endpoints of one diagonal of the quadrilateral are w and y. So I'm going to connect w and I'm going to connect y. Where's my ruler there? And then the endpoints of the other diagonal are x and z. It's important to make sure you follow directions and connect the right things. Okay, so those are my diagonals. All right, looks like if those are my diagonals, probably had a kite. They said diagonals are congruent. Well, visually, that's just not going to happen. It's just not. They're not congruent. If you wanted to check it, though, you can always, if it was a really close call on a test, remember you can always make a right triangle and do a little Pythagorean theorem to figure out the length of xz. Again, you could do another right triangle for wy, figure out that, but they're not congruent in this case. Diagonals are perpendicular. All right, well, we can check that. The slope should be opposite reciprocal. So let's check that. Slopes. Grab my highlighter, right? It's just the rise or the run. So if I look at this purple line, my rise, and then my run. Okay, my rise looks like I go up 1, 2, 3, 4. And representing slope, my rise is 4. I run 1, 2, 3, 4, 5, 6, 7, 8. Alright, so my first slope is 4 over 8, same thing as 1/2. Alright, let's check wy, same idea. Same idea, we gotta check the slope. And I'm just gonna use the same right triangle right there, that's fine. Alright, my rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Rise was 10. My run, 1, 2, 3, 4, 5. If I simplify that, that's just 2 over 1. Now, that one's negative because I go downhill. And so the question are these two opposite reciprocals? And absolutely they are. So yes, diagonals are perpendicular. Diagonals bisect each other. Do they cut each other in half? Is this the midpoint? No. I mean, probably from x to z, that is definitely probably the midpoint. And you can just check. Use a little logic, right? I go over 4 boxes at 2, over 4 at 2. All right, so definitely the midpoint. But as far as wy, it does not bisect wy. So I can't say diagonals bisect each other. No, not both of them. Most descriptive name for the quadrilateral, that is a kite. That is a kite. We connected, if we actually finish this off and connected, you just have yourself a nice pretty kite. Very nice. Alright, number 9. ABCD is a rhombus. Okay, it's a rhombus. They say AD is 10. Okay, so I'm going to write that there. And DO is 5. Alright, they want you to find OB. I want you to find BC. And the measure of AOD. AOD, right in there. Okay, so just remember in a rhombus, it's a diamond, right? Shine bright like a diamond. Alright, so diamond, all your sides are congruent. Which really gives away why, because all these sides should be 10, all of them. They're all congruent in a rhombus. Okay, so if I find BC, which was my y, that's 10. Boom. Also note, diagonals bisect each other in a rhombus. They do. So this is 5 here. Down here is also going to be 5. So OB is 5. And the measure of AOD, last little thing, they bisect each other and they're 90 degrees. All the angles are 90 degrees. So they wanted AOD, O is the center, AOD, you're talking about a 90 degree angle there. Boom. Alright, back page. 10. 10, okay. So, I'm sorry for the blanks here. Okay, this is a really awesome problem. So they got, looks like they got a kite right up top here on top of an isosceles trapezoid. Cool. So if I just like pick this apart, let's start with what we know, which is the top is the kite. In a kite, I know that this angle up here will be congruent to here, so that's 105. If I want to find x, again, this is a quadrilateral, so we're just going to add what we got, subtract from 360. Alright, so 105 plus 105 plus 24. Okay. It's 234. Let's take 360 and subtract 234. Righty. Okay, so something like that. So x is equal to 126. Alright, cool. If I want to figure out y, alright, so let's use with the markings. They had a little arc here with a little tick mark and an arc here with a tick mark. That means they're congruent, so this is 105. Alright, if I only know one angle, but I know this is an isosceles trapezoid, so remember isosceles kind of means this, right? You got two sides that are congruent. And it's like having two hands and 2 feet that are also congruent. So my hands are like above my head. This is 105. Up here is also 105. And my hands. Yay, 105. Okay. My feet are below. Alright, they're also congruent. So y and whatever this is the congruent. So you can do this, you can do this a couple different ways. 360 degrees in this quadrilateral. You could add these together, subtract from 360, divide it by 2 to get my feet. Or these are parallel lines, and this is your transversal. Alright, so railroad tracks cut by transversal, making these same side interior angles, the 105 and the y, which means they add a 180. So I could take 180 and subtract 105. Oops. Computer's going crazy. Give me a second here. Sorry. Alright, and we're back. So if I did that, I ended up with 75 degrees. So y is equal to 75. Done. Pretty cool. Nifty little problem there. I like it. And as always, if you want to check, just add all your numbers up, right? This would be 75. You should add all these up and you should get 360. Alright. Calculate the perimeter for the kite. I feel like we just did this problem, actually. We did just do this problem. This is a repeat of number 4. Alright, no worries. Don't need to do that. We already did it. It was 48.84 inches. Okay. 12. In some quadrilaterals, the diagonals are perpendicular to each other. Select the correct answers. Okay, so rhombus, yeah. It's very nice. You got a nice little diamond there, and when we connect our diagonals, they do make perpendicular lines, which is 90 degrees right there. Good. Square, yes. Square is a type of rhombus, so yeah, they're perpendicular. Rectangle, no. Think about a rectangle, right? If I have my diagonals like such, they're not perpendicular. This is not a 90-degree angle here. All right. Kites, absolutely, yeah. Right, so I draw a kite. Right, those 90 degrees right in there. Very good. Trapezoid, nuh-uh. Even if I draw it, right? I draw my diagonals. This is not a 90-degree angle right here. Good. Okay. All right, last one. Julian plots and connects the following points. Which best describes the quadrilateral formed? Oh, that's a great question. Let's go ahead and graph this. Okay. Okay, so A is at -3, 2, -3, positive 2. B is at 1, 1. C is at -3, positive 4. And D is at -5, positive 1. What? Okay. Which best describes the quadrilateral formed? Whew. Let's look at that. Well, that is just a good question. If I connect those, I am looking at like a heart. It's not a square, not a rhombus, definitely not a rectangle, and sure doesn't look like a trapezoid. So we're going to have to get back to you on this because I don't see an answer. All right. Have a great day, everybody. Bye-bye.